Okay, hello. Today we'll be talking about the chapter of light, and in this chapter we'll first cover the portion on reflection. Later on will be on refraction, and then finally on some of the ray diagrams. So for properties of light, right? What are some of the properties of light? Is that light will always light is a form of energy, in that it cannot be created or destroyed, and it tends to travel in a straight line. So what this means is that, let's say you have a pipe. Okay, and it's bent. Your eyes are here, and that this is a particular object. Because the light will always travel in a straight line, you will not be able to see the object. Reason being is because it is actually the light is not able to bend. However, with the presence of, let's say, a mirror here, okay, let's say this is a mirror, then a plane mirror, then the light will hit onto the mirror and then be reflected, and then you'll be able to see the person. So another thing for light, right, is that it is traveling at a speed of 3 times 10 to the power meter per second, 8 to the meter per second in a vacuum. Now this one is currently the fastest thing that is traveling in the whole world lah. So do take note that usually nothing travels faster than the speed of light, and that you are required to remember this value here. So when light hits an object, it can be either reflected or refracted. Now these two words has different meaning. Reflected is where you can see there is the bouncing of light. Okay, it bounces from one surface and then it exits the other. Whereas refraction, right? Refraction of light is where you actually have the bending of light, where light will travel into the medium, and due to the difference in the optically density, it will actually bend either towards the normal or away from the normal. Later I'll be explaining to you what is the meaning of normal. So reflection in general is the bouncing, is light being bounced off after hitting an opaque surface. Okay, provided this opaque surface, right, has to be more reflective lah. Okay, and of course reflection always allow us to see things in our object. So no matter how like wood and what's not, there is still some light bouncing away from it and entering the eyes, otherwise we couldn't actually see it at all. And in reflection of light, right, there are three main lines that you need to know about. Two main one that you need to that comes from light. They are your incident ray and your reflected ray. So what does this mean? So let's say you have a plane mirror. Okay, on which is like on this horizontal graph surface. So this is the plane mirror. The dotted line that is 90 degrees from the plane mirror, this is what we call the normal. And so when light is being shined and it hits the surface, okay, this is what we call as the incident ray. And the angle formed between the incident ray and the normal, which is this one, is what we call the incident angle, or angle of incidence. Next, of course, due to reflection, the incident ray will actually bounce off from the plane mirror surface, and therefore this gives rise to the reflected ray. And the angle between the reflected ray and the normal is what we call the angle of reflection. Now in this case, this is quite typical in any of the reflection of a light, and one of the law of refraction is that the incident ray, the normal, and the reflected ray must all lie in the same plane. Okay, and that the angle of incident and the angle of reflection is the same. So you have the rough and smooth surface appearing at different to our eyes due to light being bounced off from one item to another item, and that this surface will actually appear smooth. So this is in the event of having regular reflection, where you can see they are generally parallel to one another. So what you can see is you can see a very sharp and clear image. However, when you have light rays bouncing on a rough object, okay, what you will see is a lot of reflection at different angle, and this is where you call it as diffuse. So the surface will appear rough, and therefore you will actually see a very blur image. So the laws of reflection, this one is important, like how I explained just now. The normal is this line that appears 90 degrees to the black color plane of the mirror lah, the plane mirror. And in this case, right, the angle of incident will always be the same as the angle of refraction in all situations, provided that it's a smooth surface. And that the incident ray, the reflected ray, and the normal must all lie in the same plane. That means in the same space or in the same side for reflection to occur. So when we look at this kind of example, right, how to determine the angle of incident is that angle of incident, you always draw the normal. The normal, why is it dotted as compared to a solid line, is because this is actually an imaginary line. So what we can see that it's the angle here is just 90 minus 50. So the other one is 90 degrees minus 35 degrees. Get 55 degrees. This is the angle of incident. Because of the direction of the arrow, this is the angle of this is the angle of reflection, okay, by the direction of the arrow moving away. Then of course this is the angle of incident, which is the arrow moving inwards. Another thing to take note here is this is the 70 degrees, which is the angle of reflection again. So this is how you go about calculating. Okay, it's 60, where you have 90 minus 30 degrees. So image in a plane mirror, this one very important, in which one of the common question they ask is what are the properties of an image. So the formation of an image in a plane mirror is due to reflection, and one thing you will see is that the distance between the object and the image, right, they are actually the same. Secondly, the corresponding numbers, right, they are actually laterally inverted, meaning the left is the right is the left. You cannot say that it is inverted because the 6 and the 12 is still in the same position. Rather, you call it that the image is actually upright. And of course, because the distance is the same, definitely the shape and size will also be the same. And another thing to note about the image is that it is virtual. So we can see the different numbers correspond to the characteristics of the image, where virtual meaning it is the image captured cannot be done on the screen. It is upright, laterally inverted, same size as the object, and of course distance. This one, please memorize for exam. And you might be asked how to explain or what does it actually mean. Now another thing is, how do we go about constructing a plane image? So first step is for a plane image, right, you will be given a question whereby it will look something maybe like this, where you will be requested to have the to draw the image of the item. And so what you need to do is to first identify the distance to the plane mirror, and you just draw one line there, horizontal line like 90 degrees. Then after that, right, what you do next, right, is if you look at the second image, is you draw two straight lines. Two straight lines. From the ends of the eye to the image. Okay, so this is the thing to take note of. But then what you need to do is, for any lines that is after the plane mirror at the side of the image, it has to be dotted, because dotted lines means they are imaginary lines. They do not actually exist. Whereas dark solid lines, they are actually actual lines or actual rays that exist. So that's how you do it. Then next, after you've done that, the next way is to actually from the object connect to the point where the reflected ray actually touches the plane mirror. And last but not least, you have to indicate the direction of the arrows pointing towards the eye, because eye actually enters into the eye and not the other way around. Okay, and this is one complete reflection based on the ray diagram. Okay. Yeah. Next, we'll be discussing about the reflection of light. So take the time to go and read through reflection, then we'll go into refraction.